Hello, I am Aalok Sharma Kafle. Today, as part of assignment 5, I'm going to present my work of time series analysis performed on three datasets, being J17 Well Index, water levels at wells, and discharges at Comal Spring and San Marcos Spring. So to start, the first time series data is J17 Well Index, which is basically a monitoring well located in Edwards Aquifer in San Antonio, Texas in around 1913. It is named as it was 17th well drilled then by the city of San Antonio. And they monitor the changes in the water level in the aquifer. So the first step was to download the data from the Edwards Aquifer website, and after we did that in CSV format, we could import it into our environment by I did it by using Zoo library. So what I did was I just imported the CSV file first, and to look into how much data is missing or if it is continuous, I created a sequence of dates from the first day to the last day where the data was available, and then created the sequence of day for each day. And then by merging the actual data downloaded from the website to this sequence of dates, I was able to create a new data frame called here merged data frame. And looking into the merged data frame, we can see that out of all the data in all these years, 801 data were missing. So the next task was to fill up on the missing data. So to perform that, first the missing data were filled up by using any Kalman imputation method by using the impute TS library in R. So this method is basically Kalman filter algorithm used for time series filling, in this case imputation we should say. And the result that we should focus on is after any imputation or interpolation of the missing data, there should not be a large changes in the property of the data itself. So we can see the first quantiles, mean and third quantile all have only slightly changed by 0.1 fade or 0.2 fade or something similar. So after performing this and having a continuous data, I plotted the time series within the R environment. I first plotted the interpolated in the background and then the actual observed in the foreground in this plot, so that you can see we can see here that the blue lines are the actually observed ones, and wherever we see a red line in the time series, we had data missing at that phase, but we used any Kalman to impute the data at those points. And we can see it is linearly interpolating between these 2 points where the data is missing, and also trying to follow the trend that it can see on the data. So the next step was to perform the aggregation of the data, and to do this I calculated 10-day rolling average. So what it does is by putting a shift on the right side, so it is taking mean of every 10 days and then putting it as a value on the 10th day, and for 11 it will have an average of day 2 to day 11, day 3 to day 12, and so on. So due to that, the first 9 days would of course be missing on the 10-day rolling mean, but we can see a slight smoothing of the curve because of it's trying to smooth out the spikes in the both direction. To find the exact place, we can see somewhere around here the peak is higher here, and here it looks more smooth, so it happens over the graph, and it's even more clear if we increase the number of day while aggregating. So next was to calculate the autocorrelation function. Autocorrelation function was calculated for J17 Well Index daily data. So we can see there is some autocorrelation, of course, on the data that are very near to each other, but we see a cycle here at around 1 year 365. It's slightly going up, and then again at the second year cycle. So it's kind of a seasonal trend that we see, as well as the closeness to the data itself. So yes. this is showing the correlation among the values. And partial autocorrelation, we're removing every intermediate values and performing the same thing again. For example, removing the value for the second day and calculating the correlation between first and third day, and this represents our result going in both direction of partial autocorrelation, and we can see autocorrelation in both ACF and PACF here. And I performed the same task for the 10-day rolling average just to show that the result weren't. The first look at the graph, the output looks similar. Now, data decomposition. Data decomposition refers to splitting observed data into different forms. In this case, the observed data, the time series that we're just talking about, is split into trend, seasonal, and random. So for example, the value of 680 on this day, the 600 maybe came out of the trend, some of it came out of seasonal, and some of it was random. So we can see, we can decompose into 3 different types and perform individual analysis on each of them. So next task was to perform man-candle test to test the monotonic trend in the time series data, with null hypothesis being no trend and alternative hypothesis being the trend is present in the data. So I performed this by using the trend library as well as candle library. So both of them are giving a very close tau value of minus 0.03 with a very significant p-value less than 0.05. So what this says is there's a slight decrease in the trend of water depth, water level, but the trend decreases. This tau value is minus 0.03 with a significant p-value, of course. And just to visualize, I plotted the line here on the time series as well. So trend is present. Similarly, to test for the stationarity as not being the non-stationary data and alternative hypothesis being stationary, so we can see p-value less than 0.05 here with I performed augmented Dickey-Fuller test and Dickey-Fuller constant being minus 5.74. so it basically means p-value being less than 0.05. We reject the null hypothesis and say that there is a constant variation over time in this data. Then I redid the same task for both Comal spring discharge data and San Marcos spring discharge data. So for Comal spring, there were 51 days of data missing, imputed by using N.A. Kalman, and we can see some of the data missing were here in the early years, and these red lines indicate they have been interpolated by using N.A. Kalman. And of course, ACF and PACF plot for the discharge. Also, we see a slight trend here as well, and PACF showing rapid decrease as we move forward. And Comal spring discharge is also decomposed into trend, seasonal, and random data here, where seasonal value we can see is going as high as 20 and minus 20 by putting a frequency of a year. Now same man-candle test and ADF test here also shows similar trend, with trend being present and constant variance over time with significant p-value of less than 0.05 here, and the here very small p-value with tau of minus 0.03. Now for the San Marcos spring, I performed the same task with just one missing data in all of this time series between 1956 and 2023. And these are the ACF and PACF plots performed on the San Marcos spring, showing lesser trend than what we saw on Comal spring and NC17 Boyle index. And similarly, it is decomposed into trend, seasonal, and random for the San Marcos springs discharge data as well. On augmented Dickey-Fuller and man-candle test here, man-candle test is giving a tau value even smaller, and in fact it's positive with 0.004 in this case, as we can see here, and also constant variance over time with p-value less than 0.05 in augmented Dickey-Fuller. So next up was to perform the cross-correlation multivariate between different different time series. So the first was between water depth and Comal discharge. Comal's discharge value, we can see a lag, highest lag being slightly above 0 at a couple of days after 0, which shows that the Comal discharge is lagging by a few days when compared to water depth. So if the water depth of today is highly correlated with Comal springs discharge after a couple of days. And we see a similar trend here in San Marcos discharge as well, with the 17 well depth, and at the end, Comal's discharge and San Marcos discharge. I also performed cross correlation between them, with highest value again seen slightly on the right positive side of the lag axis, saying that San Marcos discharge is lagging behind Comal discharge by a few days. Thank you.